Okay, guys. Good afternoon, and welcome again to another seminars lab. Continuing our transportation and climate change season, today we have the pleasure to receive Dr. Cheng Ling from Pike Industries to talk about carbon footprint reduction in the asphalt. Dr. Cheng Ling is the Director of Engineering and Sustainability at Pike Industries, a CRH company based in New Hampshire. Dr. Ling holds a PhD from the University of Wisconsin-Madison and is a registered professional engineer in Wisconsin. He has over 10 years of experience working on the research and development of asphalt materials and sustainability in both academia and industry. Also, he is the current chair of the National Pavement Association's Committee for Asphalt Research and Technology. Let's give a round of applause and welcome Dr. Ling.
Thanks for the introduction, Renan. Good afternoon, everyone. So it is my great honor and pleasure to be here to present at the Kent seminar, and really appreciate the opportunity and the invitation from Professor Akadi and ICTT. So I always feel great coming back to the Midwest, as I graduated from the University of Wisconsin, which was my first stop since I came to the United States like 12, 13 years ago. And I always identify myself as a Midwestern, no matter where I moved to since then. So really glad to be here today and talk about the asphalt carbon footprint reductions and go over some of the key drivers, opportunities, and need from an asphalt contractor's perspective. So before I get started, I just want to give a little background information about my company, Pike Industries. So Pike is the largest asphalt and aggregate producer in New England, and it went through 5 generations before being acquired by CRH, which is our parent company. And Pike has been in the business for 150 years. And this picture shows a prototype batch plan, asphalt batch plan, which was in service for Pike between 1923 and 1943, so 100 years ago. So the plan was capable of producing asphalt mix in 500-pound batch and at a rate of 7 tons per hour. So the plan at that time allowed the Pike crew to no longer hand mix the hot asphalt. So it was a milestone for the company and also for the paving industry, just considering that happened 100 years ago. And currently, Pike operates 26 asphalt plants, 13 sand and gravel facilities, and 22 stone facilities throughout the 3 northern New England states, New Hampshire, Maine, and Vermont, and employing over 800 people. And as I mentioned, Pike is a subsidiary of CRH, our parent company, which is a public-owned corporation based out of Dublin, Ireland. Just a little bit about our parent company, CRH. CRH is one of the largest construction building materials business in the world, and employing over 75,000 people at about 3,200 different locations in 29 countries. And our operations span 29 different countries on 4 continents. And in North America, we are the largest building material business in this continent, with operations in 48 US states, just beside Alaska and Hawaii, and 7 Canadian provinces. And on the other side of the Atlantic, we are also the largest building material business in Europe, with operations across 23 European countries. And in Asia Pacific market, we also have a regional leadership position. So this is what we're going to cover and talk about today. I'll first give a little background information about the biking policies, the EPD implementation status, the NAPA asphalt EPD generation tool, and the recent NAPA benchmarking effort. And then spend some time to talk about some of the key drivers and improvement opportunity, especially for the asphalt producers and contractors. And then I'll touch on a little bit about the research and implementation needs, not just for the asphalt contractors, but for the whole asphalt industry. And then wrap up my presentation with a couple key takeaways. So this is a snapshot that I took from the Federal Highway Administration Sustainability website. You can see the three states that are highlighted in green. Those are the states that have legislated the bike clean policies to date: Colorado, Oregon, and California. And for the other states that have highlighted in dark blue, those are the states that have considered the bike clean policies over the last couple of years. With the most recent update from the state of New York, who just announced the adoption of their bike clean policy through the governor's executive order in late September, just several weeks ago, which requires the contractors to submit the EPs for a variety of different construction materials, including asphalt. And according to the Federal Highway Everyday Count Initiative (EDC7) summary report and summit summary and baseline report published earlier this year, so you can see as of April 2023, there are just 3 states that are currently under the demonstration, assessment, or institutionalization of EPD, including Colorado, New York, and Minnesota. Oops. However, by May 2025, which means within the next couple of years, there will be 19 states who have already set the goal to implement, assess, or demonstrate the EPs for the sustainable project delivery. And Illinois is one of them as well. So before I move forward, just wondering, how many of you in this room have not heard about EPD? Great. Looks like everybody has been familiar or at least heard about it, right? So what EPD does is it communicates the environmental impact of a specific product or material, just like the nutrition label does on food. And this is an example of asphalt EPD generated using the NAPA EPD tool for a mix out of a Pike facility. So you can see it communicates a number of different environmental impacts, 5 different types of impacts, with the current primary focus on the global warming potential, which is what we are talking about a lot today. And one of the things that I want to note is for the asphalt EPD, the current scope is just limited to cradle to gate. That means only the materials, transport, and production. Those 3 stages are included. And beyond that, in a post-production transport, which is A4, construction A5, use, maintenance and rehabilitation, and end of life, those cycles are not currently included or considered in the asphalt EPD. So this is a significant data gap existing, and both industry, agency, and academia need to know about it. And this is just a quick peek of the NAPA Emerald Eco Label EPD tool. If you haven't, if you've never seen that or haven't got a chance to take a look at it, I would encourage you to check it out just by typing asphaltepd.org. And the tool was designed mostly for the asphalt producer to generate the asphalt EPDs. However, even if you're not a user or if you're an asphalt producer, you will have access to all the published EPDs. You can see all the published EPDs from this website. from every state. And that potentially, if you need any information, for example, for research, you can just go into the each EPD from each individual state and check out the information. And another great thing coming with this tool is it has a module called EPD Optimizer, which would allow the user or the asphalt producer to see the impact on EPD from the variable change, such as the hot type, hot distance, and fuel type, etc. And get an idea, how to possibly optimize the EPD for a specific case. According to NAPA, that as of January 2023, earlier this year, right before NAPA annual meeting, so there had been over 400 mixes with published EPDs. And from 7-day plans across the 25 states, and the number probably had gone up significantly over the last 10 months or so. And in the summer, NAPA launched their first benchmarking effort across the country and industry in order to get an idea about where the national asphalt EPDs average stand. So the effort was quite successful, and NAPA was able to collect over 1,000 mixes out of 336 plans from the 91 different organizations and companies. And this is where the national average number stands so far from that first benchmarking effort. So from A1 to A3, the total average is 69.2 kilograms per mixed ton. And with the breakdown also listed here at each of the 3 stages. And the one thing that you need to keep in mind, or they noted, is this number, along with the average at each of the 3 stages, varies very significantly from state to state and region to region. So for the specifying agency, especially the state or the local agency, they should not use this number directly to be included in any EPD related specifications they would do in the near future. If you are interested in learning more about the details about this first benchmarking effort, NAPA actually just held a webinar just a couple of years ago, releasing all the details regarding this effort. And I believe the recording will be released very soon. So feel free to check it out if you're interested, and it is free to academia. So sign up on NAPA account and you will have access to it. All right, next I'll spend some time to go over some of the key drivers and improvement opportunities, mainly for the asphalt producers and contractors. Here's a general list of the key drivers at each of the 3 stages. At the material stage, A1, the total binder content and the recycled binder content will drive the virgin binder demand, which is the highest CO2 generator in our asphalt mix. And the recycled aggregate can sometimes have a pretty significant role as well, especially in the aggregate pool regions or states. And at A2 stage, transport, the hot distance of the ingredient materials, such as the virgin binder, the aggregate, and also the recycled material, can have a pretty significant impact as well. During the production stage, A3, there are a couple main focus areas. The first one is related to the BTU consumption, which is the energy consumption at the plant. So that is heavily affected by the moisture level in your stockpile, and also the plant production temperature. And another big piece is about the burner fuel. Depending on the type of the fuel type, and also the heating efficiency and the installation at the plant, that could play a pretty significant role as well. And among those different drivers or factors, some of them are relatively controllable to the asphalt producers and contractors, like those highlighted in green. And some others are controllable to a less degree, such as the hot distance of the ingredient materials and also the fuel type. However, this is not a rule, and it may not work the same way for everybody. So for each individual asphalt producer, they should evaluate their local mixes and the operations to determine their own impact. So this is a figure made by my colleague, Dr. Shane Buchanan. Some of you may know Shane. Basically illustrating the impact, the CO2 impact from the isolated variable change related to a base case. And the base case here is a mix with 5% total binder, 20% wrap, no shingles, average aggregate haul distance of 20 miles. The plant production temperature is 310 degrees. And the stockpile moisture is around 5%. And the burner fuel used at the plant is the natural gas. So on the left side of the figure, those green bars basically represent the better scenarios caused by those each individual factors. And on the other side of the figure, those red bars represent the worst scenarios. So I'll walk you through the several examples on each side just to give you a better idea about how each of those drivers or factors can really affect the CO2. So starting from the far left side, aggregate haul distance. Now it is at 20 miles. If we switch from 20 miles to just truck 1 mile, basically using the locally available aggregate source, we could see a significant reduction of 1.98 kilograms CO2 per mixed ton. And if we go to the next example, if we increase the use of the wrap in our mix from 20 to 25%, 5% higher, we could see a reduction of 1.79 kilograms. And if we can do a better job controlling our moisture at the plant and in our aggregate stockpile, we could see a reduction of 1.47 kilograms. So those are just a few examples here on this side and on the other side. Say if we don't have natural gas and we had to use the propane or other type of fuel, you see how much it can increase. Using the propane for this specific mix, it already increased by 2.6 kilograms, and we had to use the number 2 oil, it increased even more dramatically, up by 5.56 kilograms per mixed ton. And if we don't have any suitable aggregate source within the 20-mile distance, and we had to truck further, say 50 miles. 50 miles away, and we would see an increase of 3.14 kilograms per mixed ton. So those examples are just giving you an idea of how each of those different drivers or factors can really affect the GWP or the CO2 from this example mix. So let's take a further look at a couple cases or examples at each of the 3 stages: material, transport, and production, and see the sustainability impact and what kind of opportunities may exist out there. So on the material side, wrap, recycled materials is one of the biggest things that we want to continue to push and also to take advantage of. So in this example, if we compare a standard mix with 20% wrap versus a mix with increased use of wrap up by 20%, so to 40%, we could see a decrease. We could see the reduction of the CO2 from 51.5, 43.6, and with the majority of the reduction actually coming from A1, just due to the replacement of the virgin binder and virgin aggregate. So that said, every 1% wrap would have an impact of 0.35 kilograms CO2 per mixed ton. So we see the significant sustainability impact as the asphalt producers and contractors. How can we really seize such opportunities? One of the first things for the asphalt producers is to maximize the addition of the use of recycle, especially on the non-agency mixes, and take advantage of the use of the rejuvenator to balance out the stiffness and relaxation properties coming from the recycled binder. And we should also maximize the residual binder in the recycle through better wrap management and processing, and consider the final grind size for the recycled asphalt shingle. Contractors need to consider and invest on the plan modification, such as increasing the recycle base, change the fly design within the drum, switch between the drum and plan types, and increase the size of the wrap color, etc., in order to accommodate the higher recycle use through a better feeding system. Contractors should also limit the moisture in the wrap, work closely with the specifying agencies on their specifications. So another big part on the material side is about the virgin binder demand. So asphalt producers should always right size the total binder in the mix, especially avoid over designing the VMA. As every 0.25% VMA equals about 1/10% of the binder, which would have a sustainability impact of 0.57 kilograms CO2. And also, the producers need to consider the asphalt absorption whenever possible when selecting the aggregates, because if we compare the aggregate blend with just 1% absorption versus 0.7% absorption, so such 0.25% absorption would have an impact of 0.72 kilograms CO2. So at transport stage, aggregate sourcing can, and also aggregate transport can greatly impact the CO2, especially for the aggregate poor states and regions such as Florida and Louisiana. And this figure was taken from NAPA first LCA, asphalt mix LCA report, which was published in 2016. And it illustrates the impact of the haul distance, which you can see from the 4 bars on the left side of the figure, and also the impact of the haul type, either by truck, by train, by barge or vessel. And you can see how different those numbers are. So the locally available aggregates used can reduce the CO2e impact. However, as a producer and also agency, we need to keep in mind that the performance also must be achieved. So on the production, there are a couple main pieces for the asphalt producers that we need to continue to work on. The number one thing is about the stockpile moisture, because the moisture exists in the aggregate. It either needs to get drained out or dried out. And the producers need to consider the paved and sloped stockpile areas for better drainage for the moisture, and consider using the cover over the stockpile. Implement the load out best practices, such as reading the bucket up and load out from the high side. And also watch closely on the aggregate supply management, especially prevent wet materials being shipped. And usually a good communication between the asphalt producer and the aggregate supplier goes a long way. And there's a rule of thumb called 1-11-11, which is every 1% moisture in the aggregate reduction can reduce the BTU consumption by 11% and increase the production rate by 11%. And another main area on the production is the plant production temperature. And for the asphalt producer and asphalt plant, they really need to evaluate and determine if a lower temperature is achievable at the company level and also the plant level, just by asking themselves a list of questions like this. The production temperature is really hot. As the temperature crept up over the years, and this plant have a foaming system. and has the foaming system be used optimally? And can this plant really run chemical warm mix technologies to drop the temperature, but without any undue risks? Every 25 degrees temperature drop or reduction can have an impact of 0.67 kilograms CO2 using the natural gas. And as you can see here, using other type of fuels such as propane or residual fuel oil, that impact will be even more significant. So we've just talked about a couple examples at each of the three stages, such as the use of the recycle and virgin binder demand on the material side, and warm mix or temperature reduction and the moisture control on the production side. And here is an overview or summary of the sustainability impact from each of those key drivers. And for the recycled asphalt pavement wrap, every 1% wrap would have an impact of 0.35 kilograms CO2 per mixed ton. And every 25 degrees temperature drop can reduce the CO2 by 0.67 kilograms if using the natural gas. And every 1/10% of the binder reduction can lower the GWP by 0.57 kilograms. And every 1% moisture reduction can reduce the CO2 by 1.47 kilograms. So just a disclaimer here, those are just general estimates based on a specific example mix, and everyone's local condition will drive the actual data. All right, next I'll touch on a little bit about the research and implementation needs, especially from the research for the research community, but more for the whole asphalt industry. So on the materials, we need to continue to search new forms of a binder and all the binder replacement, such as the biogenic materials like the bio binder, bio asphalt, etc. We need to investigate the carbon sequestering synthetic aggregates, which has been studied and investigated in the concrete ready-mix industry, but not much in the asphalt area. And we need to continue to push and increase the use of the recycled asphalt materials, especially beyond 40% binder replacement. And we need to look into and research the use of other recycled materials from the circular economy standpoint, such as the rubber, glasses, and plastics, which is pretty hot topic these days. And in some of the specific states, we need to eliminate or reduce the use of hydrated lime, which is a very carbon intensive product. However, we need to ensure the performance by doing so as well. So on the mix design, as a producer, we definitely want to leverage the balanced mix design to improve the mix performance and optimize the ingredient materials. And producers need to support agency and work closely with them to develop the BMD specifications. And on the production, we just talk about a few best practices for better moisture control. However, we also need to find a better way to implement those best practices at the company level and at the plant level. And producers and contractors need to continue to evaluate and look into the temperature reduction technologies, such as warm mix asphalt, half warm mix asphalt, and cold mix technologies. And producers need to look into and consider the investment on the plant upgrade or increase use of the recycle, and also improve the energy efficiency, including both the electricity and also the fuel at each of their plant. So NAPA has been working with EPA over the last few years and developed a program called APEX, Asphalt Plant Energy Performance Peer Exchange, which is a great tool for asphalt producers to monitor the energy use at the plant. And the construction is more currently included in the asphalt EP scope, if you still recall the first couple slides when we talked. However, there are some things for the asphalt industry that we probably could and should do sooner than later, such as the equipment electrification, the rotor pattern optimization and intelligent connection, and eventually toward the automation of the construction. So one of the things that I want to highlight is about the partnering as an industry to lower the asphalt carbon footprint. And you might have heard about this from Magdalia from Federal Highway a few weeks ago. That Federal Highway, they launched a program called a Climate Challenge last year, which I believe is a great example of this. So the program identified more than 35 projects from 27 agencies, including both state agencies and local agencies, and provided over $7 million together with some technical assistance for those specified agencies. And one of the specific requirements for all those submitting agencies is to work closely with the industry, including asphalt producers, contractors, academia, and consultants, etc., on those projects. So it is very likely that over the next few years, the outcome of those projects will have a significant impact on the development and implementation of the EPD-related initiatives across all these different states. And Illinois has a project as well, which is focused on the dolomite quarry byproduct used in the local roads. So I guess Professor Tom probably got involved as well, right? So, all right, just a couple key takeaways to wrap up my presentation. So as you probably have noticed, that the leading practices that save money almost always have a positive sustainability impact, such as reducing the aggregate moisture, lowering the production temperature, reducing the virgin binder demand or needs, increasing the use of the recycle, using the locally available aggregate, and so forth. So as the asphalt industry, and specifically for asphalt producers, we are just having another good reason to do the right thing. And besides, the sustainability impacts must be considered in the decision-making process. As in the cost-benefit analysis, both financially and sustainability need to be included now. Then I'd like to thank you all for listening, and that's all I have. Yeah, I'd be happy to take any questions if there's any.
Thank you, Dr. Ling, for this nice presentation. I'll open now for questions. Professor Raj.
Thanks, Cheng. This was a really great presentation and really exciting stuff. I have maybe two questions on the material side of what you presented. First one, how do you see the future going as far as volumetrics? One of the directions, of course, to reduce virgin binder demand, maybe use more recycled, is this balanced mix design perspective, but it's still tough to do when you have a VMA criteria, VFA criteria, those kind of same. Do you see those things changing in the future? I know some states are already going in that direction, but how do you see that as an industry we're going?
Sure. So from the industry side, we definitely want to see that going away as soon as possible, because as you mentioned, it's just another very restrictive specification. We want to push the balanced mix design, if we just want to see an additional layer of safety or making the agency feel comfortable by adding the performance tests, we are just making the specification even more restrictive. So which is not the purpose of the balanced mix design. So however, from the agency side, I can see where they're from, because they don't want to take too much risks and they want to do things slowly, very slowly, which is not a good sign, but it's a process. So I'd say, as I mentioned, so for the industry and the agency, we need to work closely and together and to make sure while we achieve the transition of the balanced mix design, but also ensure the agency and contractor both take the minimum risk as much as possible. So I think that's our approach. That's why we are having 4 different approaches, from A to D. So every agency can pick the comfortable level of the approach as they want. If they don't want too aggressive, they can pick B or C, right? After starting from A, obviously. But some of the, I guess very few of the agency would be open to approach D, which is a good thing. But I would say most of the agency, they want to do that gradually. Yeah, so.
Great. Yeah, no, thanks. And maybe just as a follow-up to that, in terms of warm mix is another technology you talked about. And in terms of warm mix, we were talking about warm mix the other day in my class, and a student asked me a very good question. Typically, we have some assumption that during construction, we burn some volatiles and age the binder a little bit, which presumably helps with the running resistance. Have you encountered any situation where using warm mix, because you don't heat it up that much, doesn't get that same degree of short-term aging during construction, and then maybe some premature rutting issues in any warm mix projects?
It is a hypothesis yet to be validated, because if you ask about the warm mix technology supplier, they would tell you yes. If you see their data, yes. But that definitely needs more deeper look or analysis about not just one specific mix or specific product. It should be a variety of different product. If they do the same thing by lowering the temperature, and that the aging level from the mix can be lowered as well. So I wish I could see a systematic approach, especially like a master thesis, something like that, just looking into the problem like that. Yeah, it's definitely a great hypothesis, I'd say, but no fixed answer, at least to my knowledge. So
We have it in mind as a future research topic. So some student who's looking for a thesis, so we'll talk after. Thanks.
yeah.
Any more questions for Dr. Ling?
Yeah, I had one. Can you clarify or explain how moisture is related to emissions? That was super clear.
The mix? Why we don't want to moisture in the mix? Or
Yeah, like how is it increasing emissions in the plant?
because we need to dry and get rid of all the moisture in the mix. So if we need to dry, we need to burn a fuel, right? And the burning of those fuel will create more emissions, and also will consume a lot of fuel, which itself has the scope 3 emissions as well. So that's how you can impact. Yeah, it all costs more energy basically.
Got it. Thank you.
I have a follow-up about the moisture question. So
Yeah.
From the topics that you mentioned, moisture it seems for me that it's the only one that it's actually you can do without thinking about the performance, because anyways the mix will be dry after all. So if you increase wrap, then you maybe are concerned about performance. If you increase binder, concerned about running. So moisture is something that you definitely definitely you will not see any implication of this in the performance in a way that it's gonna go out of the mixture anyway. So
Right.
why is this not yet implemented very broadly? I would say, how do you envision this? Because it seems that it should be something that is simpler to adopt, but it's still not adopted a lot.
It's a great question. So there are a lot of good practices like this, right? But most of them would require some type of investment. And from the company or business standpoint, they're gonna evaluate the return. And if they have CapEx, which is the investment money that they can put in. And some others, it's just like inertial. So just don't want to make change, and I just do my job. And for others, initiative is beyond my scope. So it happens a lot, believe it or not. It's not everyone as smart as people sitting here, right? And thinking about, from the long term, those will pay back pretty soon, but not everybody can realize that. So that's why. And as you said, if everybody can realize the benefits of that, it's just the low hanging fruit. Everybody can do it. Yeah.
My question is a little complex, so here we go. Given that you have several plants, let's assume you have a plant A and plant B. And the project is close to plant A. But the aggregate is close to Plan B. So when you are preparing the EPDs for A and B, you get B have a better EPD than A. But A is so close to the project, so in this case here, there is unfairness in the way we are preparing the EPD. I just thought about this. So the question here from you as a contractor, how do you feel about this? You see what I'm saying? You get my,
Yes,
Yeah.
spot on. I feel terrible about it. Just because, it's a gap of this EPD, especially if we just look at the cradle to gate. Because beyond gate, we can't include anything else, even the post-production transport, which is
Yes,
A4, that is
very
mentioned exactly.
important, frankly.
Yes. However, some of the agencies, they really wanna push this out.
Yeah.
And you may know one of the specific agencies is potentially looking at the limit as well, which we are far away from that spec. We are just collecting the information from A1 to A3. And we are not ready for specifying any limit because you can't look at the life cycle as just cradle to gate. So
I'm giving this question because you are one contractor with so many different plants, but now as you, I'm talking about two different contractors. So one of them now is a disadvantage unfairly.
it is very unfair if if I stay as one of them, especially that one who kind of feel unfair about it, really I would feel very upset and nothing that I can do other than just keep educating our agency, hey, this is not right and we're not ready yet, and you gotta look at the life cycle. And especially the asphalt market is low bidding market, and maybe sometime soon that EPD or the GWP limit will be incorporated into the financial wise. But eventually the market is determined by the cost and just because the nature of the market. So we cannot really just over focus on one thing by overlooking other things like the cost, like the performance, which is part of the life cycle as well. So that we talk about, we talk about EPD, we should talk about the life cycle rather than cradle to gate. So this is a gap the industry realizes, and at least NAPA is trying to keep the communications open with the specific agencies and the different policy and specification makers as well. Especially, as I said, we are not ready for setting the specification. There has already been limits coming out from EPA, from GSA. And at least in this industry, asphalt industry, we're not about it.
I had a follow-up about how moisture is handled. In the plant, is the temperature changed based on the percentage of moisture in the aggregates? Or how is the production adjusted?
Typically the heating time, so aggregates needs to be heated and dry before being blended with the liquid asphalt.
Sure.
So yeah, if you've got a pretty wet material, you probably need to dry it for a longer time. Yeah. Which will consume more energy for people.
Okay, do we have any more questions? Also, I think that's all for today. Thank you so much, Dr. Ling, for being with us today. Let's